Hi everyone, welcome to a review of the Semester 2 final. We're going to hit this like a few of the problems, not all the problems. I can't fit all the problems in a normal class period, which is also makes sense because you're not taking it in normal class period. You're taking it in two class periods. Average, you should hit about 2 minutes per question, and you should be fine. A minute and a half is ideal. And then some of them are going to take less time than that. So really when it comes out is you're going to have some problems that are easier, some that are harder, so some takes more. The test is entirely multiple choice. There are 5 answers for each problem. So there are some that are, so there's another choice. However, one of the choices is correct always. There is not a D, none of the choices are correct. So that's the format of the final. Some other questions you might have about the final, unless I hear otherwise, first, third, and seventh hours, so basically odd hours will take their finals on Thursday. Second, fourth, sixth, and eighth will take their finals on Friday. If you happen to be absent either of those days, then you'll take your makeup finals on Monday. You'll be pulled out of class. Monday is a very relaxing day, as is Tuesday. The final for Algebra 1 will be over second semester material. This decision came about after I told some classes that the final was cumulative, so I'm sorry. Looking at you first and second hour. So it's just over stuff from second semester, so you don't need to go back to your stuff from the beginning of the year. You should plan on having the review finished by end of day Wednesday. We'll play a review game on Wednesday. Finished before school on Wednesday. We'll play a review game. So my goal is to have some sort of review game that we can play together for the final. Just kind of relax and get us out there and have some fun. You may have some additional questions that come up. If they are pertinent to everyone, then what I'll do is I'll just have it so that we all either receive the message or the summation of it on Brummond, or I'll tell you about it in class, depending on how crazy it is. So, yeah, let's jump in. If you would, you'll need the following materials to be successful today. You will need your review. I would also have another sheet of paper out if you did your review on another sheet of paper, or if you did it on the paper, which I'm amazed because that's a lot. So just to note, I'm going out of order. I'm going out of sequence. The problems aren't going to be like 1, 2, 3, 4. I'm kind of hitting a few from each section. My goal is that I do one from each section, so you have an idea of how to do them all. Section. Sorry, my diction is off. Diction is when you say something, it's how you say it, how it's pronounced, and how you enunciate particular parts of the words. So you want to have good diction when you're talking. Otherwise, people can't understand you. Whenever someone kind of mumbles or slurs their words together, they do not have good diction. There's your fun fact of the day, because I don't know if it's been replaced, and if it's been replaced with something that's appropriate. If not, there you go. I taught you something. 6.1 is about graphing, so I'm going to jump to 6.2. Solving systems of equations by substitution. This is problem number 3. The way to do problem number 3 is, first we're going to go back. Pointer options. I need a pen. There we go. The way that we do problem number 3 is by substituting. That means we put this in parentheses, and then this goes in to that there. And so now we have negative 3 times the quantity, negative 1 minus y, close parentheses, minus 4y equals 2. So we distribute the negative 3 to both, which is a common mistake that people make. So you get 3 plus 3y minus 4y equals 2. Combine like terms, those two combine together, so you get 3 minus y equals 2. Subtract 3 on both sides, get negative y equals negative 1, divide by negative 1 on both sides, and you get y equals positive 1. That is your answer for that one. I'll give you a second at the end of each of them that I go through, in case you need a chance to copy it down. Or if you get lost, please feel free. Sorry, I'm eating popcorn. Feel free to send me a message. Send me a message on Remind. I'd be happy to help out. Number 6. Solving systems of equations by elimination. Elimination is where you multiply through if you need to. I don't need to because if I add these, my x term will eliminate. Number 5, you do have to multiply through one of them by a 2 to get the answer to eliminate. So this one I can just add simply as they are. My x's cancel out. And I get negative 21y plus 5y gives me a negative 16y equals 48 plus 16, which is 64, and then divide both sides by negative 16, and you get y equals negative 4. So that's my y component. I need to plug that back in to get my x. I plug it in whichever one I think is smaller. I think the bottom equation, the second equation, is easier to work with, smaller numbers. I forgot to put a 5 there. 5 times negative 4 equals positive 16. So you get negative 9x minus 20 equals 16. Write that down. Positive 16, negative. Okay. Add 20 on both sides. You get negative 9x equals 36. Divide by negative 9, and you get x equals negative 4. So then your final answer is, as an ordered pair, negative 4, negative 4. We just found y for the last one, we didn't find x. So sorry. So plug it back into the original equation. I don't know what I was thinking. So then negative 1 minus 1 is negative 2. So it's really negative 2, positive 1. There we go. Sorry, I don't know what I was thinking there. So there's the answer for 6.2, and here's your answer for 6.3. So that's number 3 and number 6. (7.10) and negative exponents. So you have to be really careful with this. Notice the negative sign is not in parentheses. There's one with a negative sign in and one with a negative sign out. So if it's negative signs out of the parentheses, really what's happening is just the 2 is being treated with a negative exponent. So the 2 moves. So the negative stays at the top, which will need a placeholder. So let's think about what placeholder we'll use. What placeholder will we use? Well, we'll use 1. So I have negative 1 over 2 to the 4th power. If you can simplify something, always simplify it. So 2 times 2 times 2 times 2. 2 times 2 is 4. Times the number 2 is 8. Times the other 2 is 16. So this gives us negative 1/16. That is different than the other one that has the parentheses. So you show me, figure out what's different. So essentially, think about what the parentheses do to the negative. This only happens if it's an even exponent. If it's an odd exponent, it'll always be negative, and then because no matter what, you'll have a negative extra left over at the end. So think about what a negative times a negative times a negative would be. So there's 7.1. 7.2 and 7.3 multiplying powers of the same base. I kind of combined this since the answers are really the same. And so what I'm going to do is I'm going to go ahead and simplify this out. What you want to do is, when you have a power to a power, you multiply. So these are just simply all multiplied together. So you're going to have 2 to the 3 times 2 times 2 power. So when you multiply together, you get 3 to the 12, or sorry, 2 to the 12. And then you can use your calculator to figure out what that is. But really, I just want you to see it's 2 to the 12. Being able to manipulate that is good. 7.2 and 7.3, multiplying powers of the same base. This one's problem number 18. This is a little bit trickier because a lot of you guys missed that these have exponents of 1. So if it's an exponent of 1, you need to give that one first. And then the 3 gets multiplied to each of the powers in there. So you're going to have negative 5 to the 1 times third, v to the 2 times third, w to the 3 times third, and then you do the same with the 2 in the back. So then you have negative 2 squared, v to the 4th, and w to the 6th. And then now that you're multiplying these with the same base, you just combine them. Negative 5 cubed and negative 2 squared are not combined in that fashion. It's not like negative 10. First, you just resolve negative 5 cubed, which is negative 125, and then we'll resolve negative 2 squared, which you notice the way that it is the parentheses, so it'll actually be a negative 4, and then we'll multiply that together. So let's go ahead and move and combine things, actually. So let's go ahead and combine pointer options, eraser. Let's go ahead and combine negative 5, so then times, so that's going to be times negative 2 squared, so that's negative 4, and then v to the 6th, combine that with v to the 4th, w to the 9th, combine that with w to the 6th. So we have negative 125 times negative 4, so that's going to give us a positive 600. So it's a positive 600. V to the 6th, V to the 4th is V to the 10th. And then W to the 15th. It should be 10. 10. Sorry, it's hard to erase on here. So there's that one. Again, always combine what you can combine, make life easier for you, and then simplify at the very end. Moving on to the last one. This popcorn is delicious, by the way. Hope none of you are hungry. If you are, I'm so sorry. Hashtag really sorry. So for 20, this one looks really hard and complicated. You just, if you're dividing, you have the same base, you subtract the exponents. And I don't know where my phone is, or my calculator, so I'm actually going to do this the cool way, which is what you guys call the wrong way. Minus 199. So really, I just round this up to 200 and then subtract 1. So it's going to be, let's see, 1,000. So if it was 200, it would be 142, but then it's one more, so it's 143. There we go. So it's going to be 3 to the 1,143. And if you put that in your calculator, you probably get an overflow error because that's a huge number. So we'd probably just leave it like that. In fact, my computer just beeped at me just making the idea of that. Just putting that in your calculator. It's just really unhappy with it. See, I can't even talk about putting it in the calculator before you. There we go. All right, moving on before my computer freaks out even more. This I tried to pick one that was really hard. This was actually used to be a question I put on a quiz. Because a lot of students would just freak out of the fraction. I don't know what to do. You can do anything that you want to do first as long as it's legal. I would say take care of the negative exponent outside the parentheses and go ahead and flip everything. So this is going to give us this. So we have b to the 7th in the numerator. And then in the denominator we have b to the 35 over 50. And this is all raised now to the 10th power. So now what I would do is go ahead and multiply everything through by 10. So we have b to the 70th divided by b. And so then multiplying this through, I don't know, it might be easier to kind of reduce this down. 5 goes into 35, what is that, 7 times? And then 10 goes into, 10 goes into 30. No, yeah, 5 goes into 35. Crazy. And then 5 goes into 50, 10. So now we multiply each of these times 10, which, as you can see, this comes out really nice because then these cancel. So we're left with b to the 70th over b to the 7th, and then those subtract. So then you get b to the 63rd. There we go. Moving on. 8.1, adding and subtracting monomials. What's the degree of the monomial? When you have a monomial, you add the powers of all the variables together. So this should be 20th. So if I wrote it out in a sentence, the degree of this monomial is 20. The end. Adding and subtracting. 27. Simplify. 8 desks plus 1 desk is 9 desks. Done. Again, when you multiply variables is when you increase their exponents. When you add or subtract them, the exponents don't increase or decrease. If you're adding desks in the room, they don't automatically become like chairs. Although you can use a desk as a chair. I guess that's a bad excuse. They don't become light bulbs. There we go. If you add or subtract light bulbs, or desks, they don't become light bulbs. Much better analogy. Standard form is when the highest exponent's first. So 8.1, adding and subtracting polynomials, 28. Write the polynomial standard form. So x cubed comes first. And then we have our x squareds. And then we simplify these two together. And we're done. Again, we can't combine any of these because we're adding, we're not multiplying. And they're different things. They're desks, light bulbs, and people. Desks, light bulbs, and people. I know it's hard to think of your x as a person, but they are. 29. Remember, when a negative is in front of a parentheses, you distribute it to both terms inside the parentheses. So we get 6x cubed, 6x cubed minus 2x cubed. My goodness, I'm jumping. Let's try this again. 6x cubed plus 49 minus 2x cubed minus 9. Combine those, 4x cubed plus 40. The end. We are done. Next one, 8.2, multiplying and factoring. I'm just going to see where we are real quick. Or I'm not. Nope, I'm not. All right. Multiplying and factoring. So now we're going to, this one's a multiply, so we're going to distribute 2x to all of these. 2x times x squared is 2x cubed. Notice I'm taking x times x, so that's increasing the power. Plus 2 times 23 is a 46. X times x is x squared. 2 times 2 is 4, and then the x gets carried along. So there's multiplying. Again, you're just distributing. Everyone gets a 2x. This one says factor. So hopefully by now you're able to look at these and see that there's a number that can come out of all of them. It is 8. So when you divide an 8 out of it, you're left with x squared, and then 2x, and then 3. If you didn't see it like this, remember you can do your factor trees. So 8x squared, we factor that down. We get 4 and 2. And then 4 gets factored down to 2 and 2. So you have 2 times 2 times 2 times x times x. Do the same with 16. So 4 and 4, 2 and 2 and 2. So 16x is 2 times 2 times 2 times 2 times x. The last is 24. 6 and 4, 3 and 2, 2 and 2. So you get 2 times 2 times 2 times 3. So they all have 3 2's in common. So that's what you would pull out. 2 times 2 times 2 is 8. So that's how we get that. This popcorn is so good. Jelly Time should pay me an endorsement for how good their big cheese cheddar popcorn is. Jelly Time. It's always time for Jelly Time. (8.3) Multiplying binomials and trinomials. This is FOIL, table, distribute. Doesn't matter to me. I'm in the mood to table, so let's table this. 2a and 4. So this is 2a squared, 6a, 4a, 12. These two combine, so you get 2a squared plus 10a plus 12. You can do any of the other methods and you'll get the same thing for your final answer, assuming you did it correctly. (38) Special case. Hopefully, you're able to see this as a plus b squared. So that means you have an a squared plus 2ab plus b squared, which means you have 2a squared plus 2 times 2a times 3 times 3 squared. Notice I put this in parentheses because it's more than just one term. So this is actually 4a squared. You got to square both parts. Plus 2 times 2 is 4, times 3 is 12, so this is 12a, then plus 9. So there's multiplying special case. So say you didn't remember that formula, you can table, you can FOIL, you can use the distribute method. Notice that when we were completing the square, they were looking like this when they were done. That's on purpose. So having this memorized is actually helpful for the later part on the test as well. Factoring, that's x squared. You know, it looks weird. That's actually how I code it to make it look like a flying 2, or the exponent for 2. That's how I do it. I use the caret key. X squared, just like you do in your calculator, actually, plus bx plus c. Factor each expression, this is the big X. Big X. Negative 75, a times c. Multiply together to give you b. b goes on bottom. So what are the factors of negative 75? 1 and 75 don't work, 2 doesn't go in evenly, 3 goes in. 25 and 3, that doesn't work. 4 doesn't go in evenly. 5? How many times does 5 go in? Actually don't know off the top of my head. I guess I gotta grab my calculator. Aha, here we are. 75 divided by 5. Oh, 15. Look at that. And it's a negative, so negative 15, positive 5. And since a is 1, we're done. These are your factors. If you split up b and did all that business with it too, you'd be fine. You'd still get the same answer. But if a is not 1, you're done. Or sorry, if a is 1, you're done. If a is 1, you're done. I'm a poet, didn't know it. Catch my rhymes all the time. I drop the beats in this mad heat. Factoring ax squared plus bx plus c. If necessary, factor out a GCF first. Pick this one because it was challenging, because you need to factor out a GCF first, otherwise you're going to have huge numbers. 3 can be divided out of all these numbers. When you do that, you're left with 3r squared plus r minus 10. Now that we have that business, big X, negative 10 times 3 is negative 30. Factors of negative 30 that add up to be 1. 6, negative 5. Now I'm actually splitting up my middle term. I'm going to split up 6 with 3. So I have 3r squared plus 6r minus 5r minus 10. If I group these, I can pull out 3r out of these, and I'm left with r plus 2. And I can pull out a negative 5 from the second group, and I get r plus 2. So my two factors are 3r minus 5 and r plus 2. And I'm done. 9.1 I skipped because it was mostly graphing. I'll do some examples with you tomorrow. 9.2, quadratic functions. Find the axis of symmetry and vertex. I picked 6.62 just because I think it was mostly challenging with the rest of them, because your formula is opposite b over 2a, and if you look, there's no b term. No b term. So that's how you should read that. So your axis of symmetry, your x equals negative b over 2a, for this one, super easy, because it's 0. Because 0 divided by anything is 0. So if I put that in, you're going to get x equals opposite of 0 divided by 2 times 4. Well, 0 divided by 8, still 0. So your axis of symmetry is x equals 0. Axis of symmetry, x equals 0. So now to get your y value of your vertex, because that's the x value, to get the y value, we just plug in 0. So when I plug in 0, we get y equals 4 times 0 squared minus 2. Y equals 4 times 0. Oops. Oh no, what did I do? No. Alright, there we go. 4 times 0, minus 2, y equals 0 minus 2, y equals negative 2. So x equals 0 is the axis symmetry, and the vertex is a point, and that point is 0, negative 2. It would be very hard to graph this because that's also the y-intercept, and we always need a different y-intercept. Our y-intercept has to be different than our vertex to be able to make a good graph. 9.3, solving quadratic functions. Solve each equation by graphing or square roots. This one should not have an r with it. I don't know if I did that on mine alone and it's not on yours, so oops. So what we're going to do is 2r squared minus 32 equals 0. We're actually doing this problem. I'm going to do square roots just because I don't have access to a way to easily graph this for you and to make sure that you all can see it. So I have 2r squared equals 32. I added 32 on both sides. And then divide by 2. And you get r squared equals 16. Square root, and you get r equals plus or minus 4. And we're done. (9.4) Factoring. So solve by factoring. So first thing we're going to do is get it equal to 0. So we actually want to subtract 21 on both sides. And put it in order from, put it in standard form. So I have p squared minus 4p minus 21 equals 0. So big X method. So factors of negative 21 that up to be negative 4, negative 7, positive 3. So we have p minus 7 and p plus 3, and that equals 0. So now we just set each of these equal to 0 and then solve. So we have p minus 7 equals 0 and p plus 3 equals 0. Add 7 on both sides. You get p equals 7. Minus 3 on both sides. You get p equals negative 3. So p equals negative 3 and positive 7. Remember to put them in order from least to greatest. There's 9.4. (9.5) is completing the square. Sorry, just making sure this was the last one. Oh, come on. Where's my pointer at? Laser. 10, there we go. Solve each equation by completing the square. So if you notice, equals 0. So we need that. Alright, so to complete the square, we don't want this to be a 13. So what we're going to do is instead subtract 13 on both sides. And we get plus blank equals negative 13. So we divide this by 2 and then square it. So we have w squared minus 14w plus 49 equals negative 13 plus 49, which I think is 33, 36. I'm going to double check. 36, okay. So we have w squared minus 14w plus 49 equals 36, which we can split this up. W minus 7 equals 36. W minus 7 squared equals 36. Square root, square root. Square root. You get w minus 7 equals plus or minus 6, because you can actually simplify that. So we have w equals 7 plus 6, which is 13, or w equals 7 minus 6, which is 1. And you notice this problem actually worked out well at the very beginning if you tried the big X method. It does work out that way too. So just happened for this one, but that's completing the square method with it. And that's a selection, a handful from each part. So hopefully now that If you haven't started it or finished the rest of it, you're able to get enough so that you know how to do each of the rest of it. This video is online. You can search under subnotes from today to find it. So if you need to go back and double check anything, or if you didn't get a chance to look over it, that would be a good thing to do. You have some time left in class, please use it to work on the review. My expectation is that you have it finished before we start class on Wednesday, so we'll do some in-class review tomorrow, and then I will see you in person tomorrow. Have a wonderful day. Bye.